Welcome to Module 6. In this session, we'll focus on how electrical and plumbing systems are integrated into SIP construction. Unlike conventional stud walls, SIPs don't have large cavities for wires and pipes. That means planning and precision are essential. By the end of this module, you'll know the strategies, tools, and best practices for running services safely and effectively inside SIP assemblies. When it comes to electrical work in SIPs, the key advantage is that panels come with built-in wiring chases. These are small channels in the foam core, set at standard outlet and switch heights, which make wiring much easier. Vertical chases are spaced about every 4 feet, and horizontal chases are set around 14 inches and 48 inches from the floor. These hollow conduits inside the foam core allow wires to be pulled using fish tape. By using these pre-cut chases, electricians can avoid drilling or cutting the panels on site, which preserves structural and thermal integrity. Now, it's very important to plan these chases during the design stage. If you need special chase locations, they should be added before manufacturing and confirmed in the shop drawings. Cutting into SIPs on site isn't recommended because it can weaken the panels. Electricians usually use flexible non-metallic cable, such as Romex, which is easy to fish through panel chases. Electrical boxes are recessed by hot knife cutting small foam pockets in the panel face. Once installed, all penetrations should be sealed with low expansion foam or sealant to maintain airtightness and fire safety. An experienced SIP installer makes all the difference here, because they know exactly where to drill in top plates, sill plates, and splines so the electrical runs connect smoothly. Lighting is another important detail. Recessed can lights are not recommended in SIP roofs. They can damage the structural OSB facers and cause overheating or moisture problems. Instead, use surface-mounted LED lights, track lighting, or if you really want recessed lights, build a furred-down ceiling below the SIP roof. Switching over to plumbing in SIPs, the golden rule is to keep supply lines out of exterior walls. If you run pipes through the foam core of a SIP wall, you lose insulation value, and in colder climates you risk freezing. Vent lines can be placed in exterior SIPs, but this must be coordinated with the manufacturer. If pipes absolutely have to be along an exterior wall, you can fur out the wall on the inside or run the pipes inside cabinets, like under a sink. But one thing you should never do is field-cut SIP facers to run plumbing without design approval. For the roof, try to keep penetrations to a minimum. Every hole is a potential air and moisture leak. When you do need a vent through the roof, keep it small, seal it with high-expanding foam, and avoid panel joints. Consolidating vents helps too, and if possible, keep them away from south-facing roof planes. That way, you leave space for a solar array in the future. There are also smart venting alternatives. Air admittance valves, island vents, or loop vents can reduce the number of penetrations through the roof altogether. So, the takeaway is this: plan electrical and plumbing early in the design phase, use the built-in SIP features whenever possible, and always protect the airtight and insulated envelope of the building. Doing this not only speeds up construction but also preserves the high performance SIPs are designed to deliver.